Ever wondered how to write clean and maintainable code? The answer lies in the SOLID principles of object-oriented programming. SOLID is an acronym that stands for 5 design principles that, when applied effectively, can lead to software that's easier to understand, develop, and maintain. The S stands for Single Responsibility Principle, asserting that a class should have only one responsibility. O represents the Open-Closed Principle, which emphasizes that software entities should be open for extension but closed for modification. L is for Liskov Substitution Principle, advocating that objects of a superclass should be replaceable with objects of its subclasses without affecting the program's correctness. I embodies the Interface Segregation Principle, which encourages the use of specific, smaller interfaces. Lastly, D symbolizes the Dependency Inversion Principle, suggesting that high-level modules should not depend on low-level modules directly, both should depend on abstractions. Let's delve into these principles one by one. First up is the Single Responsibility Principle, the S in SOLID. This rule of thumb is all about keeping your code tidy and focused. It states that a class should have only one reason to change, meaning it should have only one job. For instance, consider a class that handles user data and also logs errors. That's 2 responsibilities, and it can lead to complications. Imagine you need to modify how errors are logged. In doing so, you might inadvertently affect the user data handling, causing bugs that are difficult to track down. But if you separate these 2 responsibilities into different classes, each with a single responsibility, you eliminate this risk. One class can focus solely on managing user data, while another takes care of error logging. This separation of concerns leads to code that's easier to maintain and understand. In essence, SRP promotes separation of concerns and modularity, leading to a more maintainable and understandable system. Next, we have the Open-Closed Principle, the O in SOLID. This principle underscores the importance of software entities being open for extension, but closed for modification. But what does that mean exactly? Imagine you're designing a class, a core component of your application. As you develop your software, you realize you need to add a new feature. The Open-Closed Principle suggests that instead of modifying your existing class, you should extend it. This could be done by creating a subclass or using interfaces depending on your programming language. Why is this important? Well, by extending rather than modifying, you avoid the risk of introducing bugs into your existing code. You're not tampering with the code that already works, you're merely adding to it. This approach makes your software more robust and easier to maintain. The key takeaway from OCP is that you can add new features or components without affecting existing code, making your software more robust. Moving on to the Liskov Substitution Principle, the L in SOLID. This principle is all about ensuring that a child or derived class can stand in for its parent class without the program going haywire. Think of it this way, if you have a bird class with a method for fly, it works perfectly for a sparrow. But what about a penguin? Penguins are birds, yes, but they can't fly. If we use the penguin class, a derived class of bird, and it can't use the fly method properly, we've violated the Liskov Substitution Principle. To adhere to LSP, we must ensure that our child classes can be substituted for their parent classes without causing issues. This might mean rethinking our class hierarchies or how we're using inheritance. Remember, LSP ensures that our abstractions are correct, leading to a more reliable and flexible system. Next in line is the Interface Segregation Principle, the I in SOLID. This principle is all about breaking down large, unwieldy interfaces into smaller, more focused ones. The idea is simple yet powerful. Clients should not be forced to depend on interfaces they do not use. Let's imagine we have a large interface that includes methods for printing, scanning, and faxing. Not all devices need all these methods. A printer, for example, doesn't need the fax or scan methods. So instead of one big interface, we segregate it into 3 smaller interfaces. One for printing, one for scanning, and one for faxing. By doing this, we ensure that each class only needs to know about the methods that are relevant to its operation. This approach gives us a more flexible and maintainable system. It also makes our code easier to understand and modify. ISP helps in reducing the side effects and frequency of required changes, making your code less error-prone. Lastly, we have the Dependency Inversion Principle, the D in SOLID. This principle is all about promoting flexibility and maintainability in our code, by reducing direct dependencies between high-level modules and low-level modules. Let's take an example. Imagine we have a high-level module like a payment processor, and it directly depends on a low-level module, say, a credit card payment method. This direct dependency can make our payment processor less flexible and harder to maintain. Enter dependency inversion principle. It says, instead of the payment processor depending directly on the credit card payment method, both should depend on an abstraction, like an iPayment interface. This way, if we decide to introduce a new payment method, say PayPal or Bitcoin, we can simply create a new class that implements our iPayment interface without needing to modify our payment processor. DIP encourages us to avoid tight coupling and instead rely on abstractions, promoting a more flexible and maintainable codebase. So we've covered the solid principles and how they can help you write cleaner, more maintainable code. Let's quickly recap. The single responsibility principle reminds us that a class should have only one reason to change, encapsulating just one functionality or behavior. Next, the open-closed principle emphasizes that software entities should be open for extension, but closed for modification, enabling new functionality to be added without altering existing code. The Liskov Substitution Principle dictates that objects of a superclass should be replaceable with objects of its subclasses without affecting program correctness. The fourth, Interface Segregation Principle, promotes creating specific, smaller and more cohesive interfaces. Finally, the Dependency Inversion Principle suggests that high-level modules or classes should not depend on low-level ones directly. Instead, both should depend on abstractions. Remember, the solid principles aren't rules but guidelines that can help you become a better software developer. Happy coding! Before we wrap up, we'd like to take a moment to acknowledge the creator of this content. This video was generated by Ahmad AI, a creative scriptwriter with expertise in adapting and expanding existing scripts for various types of media. If you have any questions about the solid principles or any other topic covered in this video, please don't hesitate to leave your comments below. We're always happy to engage in discussions and answer any queries you might have. Thank you for watching and for supporting our channel. Remember, the journey of becoming a better software developer is continuous, so keep learning and keep coding.
Continuous Learning. Code Books Academy. Thank you for watching.